team, I just want to go over some things real quick. I'm not going to go through the whole answer, but I do want to point out some things because I know they are progressively, I don't know if they're getting more challenging, but they're just different from the example that I showed you before. So just talking about the magnesium with the sulfuric acid, you had the magnesium, which is becoming the magnesium 2 plus ion. We obviously knew the magnesium was reacting because the magnesium was starting to disappear. When it came to the sulfuric acid, you had two choices of what could be reacting. It could have been the hydrogen ions or it could have been the sulfate, there you go, ions. But because we know they were bubble forming, it then narrows it down to sulfur dioxide and what's the other one? Hydrogen gas. We figured out it is hydrogen gas because it was flammable. So you're starting from H plus going to H2. So just kind of filling that in. I won't fill in the rest of it because I don't think it's necessary and I don't want to waste time too much. Do be mindful with the observations and the linkages. You need to be talking about, for example, the magnesium was the gray metal. We know it was part of the reaction because it disappeared. And the reason why it appeared to disappear is because it actually went into solution as a colorless ion, Mg2 plus. Which is aqueous in solution, so it can't dissolve. The other thing is noting that, you had hydrogen ions. Again, you couldn't see them, but they are in solution. They are colorless ions. We noticed that bubbles were forming, and since bubbles were forming and they were colorless bubbles, we know that it's hydrogen gas that was coming out of there. The one I want to kind of talk about, though, is the electron transfer and the half equations, just to make sure you guys are doing those correctly. I'll start with the half equations, and then I'll backtrack. So with magnesium, we know it's going from Mg to Mg2 plus, and with that, it is losing 2 electrons. I'm going to turn this that way so I can actually write them. Are we okay with that? All right. The next one was hydrogen, which is H plus going to H2. Now, this is where it's starting to get more complicated because we now need to start balancing our equations. This is a 1 on this side, and that's a 2. So in order for me to balance it, I can only add coefficients, which is numbers in front of stuff. And the way I'm going to do that is by adding a 2 in front. Okay? The next thing I need to do is add my electrons. So in this case, it is going to be gaining 2 electrons. So we're doing E2. Now, the next thing I want to add is to make sure you guys don't get confused. So in this case, we have magnesium has lost 2 electrons to form Mg2 plus. In this case, however, you have 2 hydrogen ions, so we have to be careful with how we describe it. We have to talk about how each hydrogen ion loses 1 electron, because when you see it, there's 2 here, there's 2 here, so per hydrogen ion, it is 1. So watch out for that and make sure you're clear on that. So each H plus ion gains, sorry. So just watch out for that. Just being really clear that you understand that it's 1 hydrogen ion that's losing 1 electron, not 1 hydrogen ion losing 2, or gaining 2, sorry, etc., etc. So just be mindful whenever we're writing our justifications, we're talking about per 1. Okay? It does come up a bit because certain times you're going to have things like this. And then when you put these 2 together, nice and easy because this is 2 and a 2, so there's no multiplication required. You can just smash them together and they're fine. All right? If they weren't fine, then you'd have to do some multiplication. All right? Questions, concerns, comments? Or are we okay? Good? All right. That's all I wanted to cover because I know that was a common kind of area that people have made mistakes on. The other one you guys can practice writing up, which I suggest you guys do for homework, is the one that was the magnesium with the oxygen gas. I think that one does actually require you to do some balancing and multiplication down here, which would be good practice. What did I want to add about that? It's not on the resource sheet, but magnesium oxide is a white powder when they're together. Currently, a lot of the things listed on there are all in the aqueous solution form. That one is white powder because we're lighting it on fire. Cool? Yeah, that's good. All right. I'm going to stop it. You guys can keep working. We got a couple more minutes, so you can probably get something done.